Yes, hello and welcome to this part 2 of the lead button project. So in this project, I've done a slight modification to our LED connection. Instead of grounding, I'm adding power, so it's going to be active, like it's going to light up when this line is low. Okay, so also I'm going to add a virtual terminal. So go over here to instrument modes and click on virtual terminal, then we put it there. So we connect this via the UART. So yeah, via the UART, you can connect your virtual terminal to the microcontroller via the UART. Make this a little bit better or clearer, like that. Okay, so you connect to TX. TX is transmission, and here on the virtual terminal you connect to RX. RX is receiving, okay, or reception. The virtual terminal can send information and receive at the same time. Okay. Yeah. So UART is short for Universal Synchronous Receiver Transmitter. Okay. Asynchronous means it does not have to depend on the system clock. Okay. It just depends on a certain protocol. In this case, we'll be using a baud rate of 9600 bits per second. So yeah, this is it for now. So each time you press a button, the LED either lights up or turns off, and then a message here is recorded, like button pushed or something. So yeah, let's head over to our mikroC Pro. We're going to create a new project basing off of the previous project, which is this. So it's going to be a slight modification in the code here. I'll copy everything. Yeah, copy everything and then create a new project. So yeah, standard. I'll just call it lead button 2. So I'll click next, then finish. Yeah, and in here you can paste this code. So under initialization, we are going to initialize the UART. So just simply type UART. This is going to be UART1. The function we use is UART1 init for initialization. We initialize it to 9600 bits per second. So that is our initialization for the virtual terminal. And then here under mikroC libraries and the system libraries, don't forget to include the UART library. So just tick it, it will be included to your project during compilation. Okay, so initialization is done. Now for this part, as LED toggles, the message is also written on the screen, so we should have something like UART1, UART1. So the function is write text, and what else? So we can put the message you want to appear here, something like button pushed. So I'll put a new line, so each time we press, the new message goes on the new line. So something like that. Okay, so that is our message. And what else? So since since the LED is going to be active while low, means we need to initialize that pin to just initialize the pin to, okay, let me first save the C file. Yeah, so it means we're going to initialize the pin F0, should be F0 with capital F0. So initialize it to 1, so that the MCU starts when that pin is high, and when it's high the LED should be off, so that if you press the button then it will be low. Okay, yeah, so for the button state it doesn't matter, this is going to be a button push. Each time the button is 1, it's registered as a button push. So that is all the modification we need. So I'll simply build this successful, we don't have any errors. So I'll come to our MCU and then double click, check this, and load our program. So I'll click OK and run the simulation. So if I push the button, LED turns on, and then I see a message in our virtual terminal, button pushed. Again, unfortunately it's not going on a new line, so I'll have to check the program again. Yeah, but it says button pushed each time I press the button. So yeah, let me stop that and check why it's not going on a new line. Button pushed. Well, that should do it. Okay. Yeah, okay, so for our button push message, instead of new line, I'm supposed to use \R for return. Okay, so if I build, so after building, double click and load the program here. Okay, so if I run this, click button pushed, button pushed, button pushed, like that. So our messages go on a new line. Okay, just like that. Yeah, so I think that is fine, right? Alright, so I'll turn this off. Now if you need any help on the UART library, if you need to know how it works, so simply go to mikroC Pro and go to the help section, click help or press F1. Now go to mikroC Pro, pick libraries, and then scroll down to UART library. Then you can look at library routines and general routines. Okay, for instance, initialization, you can check that, and you can find some examples here now to initialize. Initialize hardware UART1 and establish communication at 9600 bits per second. So just like that. Other initialization routines here. Things like that. To read from the UART. So you can as well check the function I just used. I want to write text, so something like that. Yeah, okay, so I think you can start from there. So for those of you who don't know what a virtual or what a terminal is, for instance, a terminal is just like any other PC. PC has a serial port In this case, that serial port uses the UART protocol. So this is actually what we represent in our MCU. This is our UART. Okay, this is our UART. So the serial connection to the PC, and then serial connection to the microcontroller via a MAX232. Okay, so something like that. So this is that kind of connection, although we ignore this entirely. Okay, but we can choose to put it there, but we ignore it for simulation purposes. But this is how the connection is supposed to be. Okay, and this jack is called the RS232. Same case here. So it connects and then we're able to send information via from PC to the MCU and back. So the PC in this case is represented by our this virtual terminal. Okay. Yeah. So okay. All right. So until we meet next time. All right.